Hello and welcome to Maths with Mr Amison. In this video I'm going to be talking to you about how to apply trigonometry to 3D shapes. If you need a recap on how to do this, then please watch the video here or follow the link in the description below. I'm going to give you an example, then I'm going to let you have a turn and go through that example in detail. Then I want you to have a go at seeing if you can find the answers to 3 questions I'm going to give you. So first of all, I'm going to find the angle ECN, and then I'm going to talk you through it once it's done. Alright, so in order to find the angle ECN, I first had to identify a right angled triangle that would be useful. And in that, it just so happens that because N is the centre of CB, then we know we have a right angle at N here. So we can do a right angle triangle ENC. Because of that, we're trying to find this angle here. We're given the 2 shorter lengths, we're given the opposite side, and we're given the adjacent side. Therefore we can use tan. So tan x is 5 over 2. And because of that, we can do inverse tan of both sides. To get x is inverse tan of 5 over 2. So therefore x is 68.2 to 3 significant figures. Alright, your turn. Have a go at finding the angle CEN. Now you've had a chance to have a go, let's think about that. Angle CEN is actually the same triangle, except the missing angle is the angle up here. And we can do this the same way. The only difference is the opposite side is now the 2 and the adjacent side is now the 5. So in this case we have tan of x is 2/5, so x is equal to the inverse tan of 2/5, which we can do on the calculator to get 21.8 degrees to 3 significant figures. So here are 3 questions for you to have a go at. See if you can find the length EC, then see if you can find the angle ENM, and then find the angle ECM. Finding the angle ECM really is rather tricky, and I'll go through the answers to these in detail. Let's do the best you can. Just have a go. Alright, so for question 1, first I need to identify the triangle that we need. To find the length EC in this case, again it would be useful for us to use the triangle ENC. And I've drawn that triangle on the side over here. This might be a useful thing for you to do yourselves. So when you've identified the right angle triangle in your diagram, just draw a 2-dimensional version in your working out. So we have 80 degrees in the bottom left, we have a height of 5, and we're trying to find the hypotenuse. So what we can use is sine. Sine of 80 is 5 over x. We rearrange, we get x sine 80 is equal to 5. Divide by sine 80, we get x is equal to 5 over sine 80. We can type that onto the calculator and get x is equal to 5.08 centimeters to 3 significant figures. Alright. Question 2. The angle ENM. Well, ENM is a right angle triangle with the right angle at M, because M is directly below the top, directly below E, therefore the line EM is perpendicular to the line MN, because it's perpendicular to any line drawn on that base. And then I just draw that triangle out. Alright. So to find the angle ENM, I need to know a bit more about this triangle, because I only have one piece of information given about the side lengths. I need to know either EM or MN. Now there's no way I can know what EM is without a bit more information either. But MN I can calculate based on the fact that M is the centre and DC is equal to 5 centimeters. So MN would have to be half of DC, so 2.5. I can then use that using cos x is equal to 2.5 over 5. So cos x is a half, which you should recognise as one of the exact values. We end up with x is equal to 60 degrees. To find the angle ECM, let's draw that right angle triangle in there. So the angle at M is again a right angle because the line EM is perpendicular to any line drawn on the base, so it's perpendicular to MC. Now, when I draw this triangle, I have the length EC from earlier on from question 1, but I don't have any other information about this triangle. I could find the length MC, I could try and find that length, or I could try and find the length EM. Now the easiest one to do is to link this with question 2, the triangle drawn in question 2, EMN. I can find the length EM by using that triangle. Now, EM is that length there which I've labelled Y. EM is the common length between the two, Y, on both of these triangles. We also know that MN is 2.5 centimetres. We can actually use Pythagoras' theorem to figure out the missing length Y by saying 5 squared is equal to 2.5 squared plus Y squared. When we follow that through, we end up with Y squared being 18.75 and Y being 4.33, and that number goes on. We need to make sure we are accurate with that number because we now need to use that in the triangle ECM. So we do that, we have sine x is equal to 4.33 over 5.08. I'm making sure I use the most accurate versions of those numbers that I can. Inverse sine of those two sides gets us x, which ends up being 58.5 to 3 significant figures. If you were close but not quite there, just need to make sure you use the most accurate numbers that you can. Alright, well thanks for watching, hope you found it useful. Bye for now.